Okay. Good evening, everyone. As usual, I would be given 5 minutes of rest time to get others to join in quickly, and so we'll get started by 8:05 p.m. So just 5 minutes, and we'll get started. Just to allow other people to join in before we get started, and so can be settled. If you haven't, you would want to send the meeting link to other people who you think would find this meeting a good one for them to join. I'm going to be dropping the link in the chat section. So you could copy it, just post it on your status, on X, Facebook if you use Facebook, and all of that. Okay.
Hello, everyone.
Yeah, Patrick.
Yeah.
Yeah. Good to have you here. So we'll get started in 4 minutes. All right, we'll be getting started right now. Good evening, everyone. My name is Ayodeji Adeoti, or Lord Sarcastic, and I'm the host at DevMeets. Today, we'll be having a wonderful topic with Ifeora Patrick Okechukwu, and I'll be discussing a plethora of topics, but all of them are under the theme which we call, you know, system design thinking and debunking myths surrounding certain anti-patterns in software engineering. This is going to be more of a discussion between myself and Patrick, and we'll be talking about several topics and a few things he he thinks are anti-patterns. We'll be having discussion for about 45 minutes. Feel free to listen in and ask your questions. At the end of the 45 minutes, I'll be given 10 minutes extra time to ask questions. I'll be given chance for only 5 questions. 5 people, 5 questions. So if during the course of the meeting you have a question, just click on the raise hand button so you are queued up first. If you don't do that on time and someone does that, I might not be able to take your question. So at the end of the 45 minutes of discussion, then I'll be taking the questions. By the way, this meeting will be recorded and it is also being streamed on YouTube. So you could decide to watch on YouTube, or if you prefer, I'll make the recording available to you soon enough. With that said, let's get Patrick. Patrick, how are you doing?
Yeah, I'm doing fine. Very fine. Thank you.
Yeah, meet you. It's good to meet you. I've
Yeah,
seen
likewise.
your face on pictures, and putting a picture to the person. It's a wonderful experience.
Yeah,
So,
thanks for that.
but would you like to introduce yourself?
Yeah, so my name is Patrick Ifeora Okechukwu. I am a full stack dev, front end heavy. I've been doing this for quite some time. Give or take, that will be 6-7 years plus. So, yeah, and I've worked in several, establishments right now, from fintech, edutech, to dabbling into e-commerce, and all of that. And I've enjoyed myself along the way. This is something that I have a passion for: software, creating, magic with software, and also solving problems as well, for people with software. So yeah.
All right. Thank you for that introduction. That is wonderful.
Yeah.
So when we're discussing, you introduce yourself to me as ISOCroft, and I think that's your name also. Yes.
Yes.
So why that moniker? What inspired that name?
Okay, so there are two parts to it. Here's the story, the short version. There's a long version, but here's the short version. I was looking for an internet name, like a name I really didn't want to use. I didn't feel comfortable. This was around, I think I would say 2008, 2009, 2010, between that period. So I was looking for a way to have my own space on the internet, carve my own kind of like small aspect of the internet. But I didn't feel too confident using my real name. So I went with, and again, most of the names that I'd like to pick, as my internet name had already been taken. So I had to come up with something on the fly. And so there are two parts to it. But I wanted it to relate to kind of like carving out my own niche on the internet. So croft is kind of like, a croft is agricultural land. So just carve out my own. So that's basically from the English word croft. Just a piece of agricultural land that can be owned or rented, so, but I'm renting a space on the internet, and ISO meaning equal, from words like, isobar, isometric, same equal pressure, equal measure, isometric equal measure, isobar equal pressure. that kind of stuff. So yeah, I'm a nerd, so I played around with, should I say nerdish words? And then yeah, I got that. I was like, okay. So I tried Isocroft, and it had not been taken. That name had not been taken. So I said, yeah, that's going to be my internet name.
Yeah, that's that sounds cool. I mean, as at 2008, well, yeah, you mentioned that most of the names had already been chosen. But as at 2008, I mean, there were still other names that could be available. So that means you must have went for like really common names. But this is a very unique name. I've not heard of it, and it's very intentional.
Yeah.
2008, I didn't wanted to do my life back then, and I I am sorry for those coming that just been born right now. All the usernames have been taken.
No, or not all the usernames, but most of the usernames that I wanted had been taken. Not all the usernames.
Yeah, I mean, like right now, any baby being born this year doesn't have any username to pick from. They just pick numbers or UIDs.
Yeah, and I don't like that.
All right. Okay. So let's get to your software engineering background. How did you get to be a software engineer? You mentioned your full stack front end heavy.
Yeah. Okay. So it was. I initially wanted to do medicine, so that's how the story, unfolds for me. I wanted to do something else. Software wasn't big back in that time. It's not like today. Like for the last 5 to 10 years, 10 years back, that tech is kind of like everywhere. It wasn't everywhere, and I had just finished writing WAEC, and this is like 2006, 2007, and I wanted to get into university. Medicine seemed like a good option, but and then I was very excited. I remember going to the National Library where I stay, close to where I stay, and I started reading anatomy books, and I got very discouraged about medicine. I took some anatomy textbooks, anatomy and physiology textbooks, and I got very discouraged because I realized very quickly, and I also started asking questions. Like whenever I went to see a doctor in the hospital, like I would ask questions like, how did you come to be, a doctor? How was this for you? How did you? And some of them took time. Some of them didn't have time to explain. Some of them took the time to explain to me. But all in all, to cut the story short, I kind of figured out over the course of 2007 that medicine wasn't what I wanted to do, or I
All right.
couldn't do it. Yeah, I couldn't do it, and it wasn't what I wanted to do. So I started, going to cyber cafes. You had these cyber cafes, and you could stay overnight. That kind of thing. We used to have them back then, and you could just stay overnight. Just a business where they had a set of computers, normal cyber cafe, and you could stay overnight. And I was just browsing. So the long and short of it all is I happened to stumble on something called Java.
Okay.
And that was where my journey began. It's like, I'm like, what is this thing? Because I kept seeing it pop up on browsers. It's like, Java this, Java that, ads even had Java. I think back then on Yahoo Mail, ads had Java. And it's like, what exactly is this Java thing? And so that's basically where my journey started from. And I started reading both online and offline in libraries, trying to understand what Java was. And then that was how I kind of like introduced myself. And I had a lot of help along the way doing that. Yeah.
All right. Yeah, that sounds beautiful. Thank you for that introduction. Let's dive into the crust of this session. Yeah, we'll talk about some topics around software engineering. So one of the first things I want to talk about is you mentioned real world modeling in software engineering as a real anti-pattern. So What do people typically think when they, or what do they mean when they say model the real world in software? And why do you think this approach is like a design trap?
Okay, thank you for that question. So the idea of real world modeling actually, started like way back when, there was this OOP craze, when Java was like the most popular thing everyone was talking about, and OOP was all over the place, was very rampant, and it was like, yeah, and even when I was introducing myself, or when I was getting introduced to OOP at the time through Java, yeah, it sounded like a good idea. It's like, yeah, model the real world. The tutorials, the examples, you had class, animal, eat, walk, the methods, all that kind of stuff. And then class dog extends animal. That was how I was introduced, and it made sense, right? On that level, it did make sense. But then as time went on, I began to have like real world experience, after learning and all of that. I studied computer engineering in university. So we did a bit of programming, Fortran and all that. But as I started to get introduced to the real world and I started having experience, working and all of that, I basically found out that, real world modeling, though it sounds great on paper, right? But doing it, the practicals of it. So theory, yeah, it's a nice theory, but doing it in practice is a bit involved. Because the thing is, take for instance, like, if you work in a software shop, right? If you work in a software shop, which I have, yeah, and you have a client come with something, they say, okay, we want this stuff. We want you to build this thing for us. It's like, yeah, fine. So we spend a few weeks on discovery, like trying to gather requirements and all that kind of stuff. And let's say you have to talk to multiple people. Now, here's what I find to be the problem with the whole real world modeling thing. And initially, we thought that if we model the real world in our software, it will be robust, it will be maintainable, and more importantly, it will be correct. Because you've modeled the real world, you've matched everything one to one, all that kind of stuff. And we thought that this was good. But you find out that reality is based on perception, right? Like if you're doing discovery and you're trying to gather requirements, you talk to this person, they're using certain language, they're using certain words, and you talk to another person and they're using a completely different word, right? Yeah. But what is common, what the common denominator between how they're speaking is the activity and the entities involved in the activity. You're speaking about activities and speaking about entities involved in activity. For instance, if you, say, let's say Google Maps, for example, right? Now, Google Maps has one objective. The software objective is try to get people from point A to point B and estimate how much time it will take them to get there. Google Maps doesn't have objects in memory that models valleys or mountains or lakes or rivers. That is not part of what, that doesn't add to what the objective of Google Maps is, right? It's just get me from point A to point B and estimate how much time it would take for me to get there, right? So the real world artifacts, like roads, traffic jams, blockades, sidewalks, they don't really exist in Google Maps. What you have are routes. Yes, there is when you're doing a live walk, where you have satellite images, yeah, that's a different experience. But like the regular Google Maps that maybe you and I or anyone here uses, just deals with routes. And there's no difference between a traffic jam and a blockade, right? And there's no, Google Maps doesn't go to extra lengths to try and highlight those, you know, in Google Maps. It's just the routes and getting from point A to point B. And if there's some kind of hindrance in getting to point B, then a rerouting happens, that sort of thing. Also take, for instance, let's say an e-commerce store, for example. You have somebody who visits the site but doesn't buy anything, right? But is looking for something, just clicks through multiple pages looking for something, right? Now, the thing is, how would you classify that person? Is that person a visitor or a user? Or is that person an unqualified sales lead, right? Like, how would you exactly, how would you classify that person? So the trouble with real world modeling, the point I'm trying to make is, we want to be able to have this simplified version of the world, right? Where one, let's say in OOP, one class maps exactly to one entity in the real world. It could be a user, it could be a record, it could be a product in an inventory, it could be, all those things. It maps to, one-to-one. There's a one-to-one mapping between an OOP class or some struct, Go struct or something, to one particular thing. But we see that, if we look through the lens of DDD, domain-driven design, we see that that's not exactly, especially when you talk about ubiquitous language in DDD, that's not exactly how it works. Like, one ID in a row in a database could be for a user, an auth user. It could also be for an addressee, right? So an addressee being somebody who has a shipping address, right?
Okay. Yeah.
That same ID, sorry?
Go on.
All right. That same ID, which is for an auth user and an addressee, could also, be for a sales lead, right? Or a marketing lead, right? Or it could also be for someone who has a dispute, right? Just the same way we do with Alibaba and, Temu. You might, come forward with a dispute between, what you ordered versus what you bought. Okay. It's not exactly. It's not the same thing. So you're opening up a dispute, right? And these things have to be, represented in that e-commerce software, right? So at the end of the day, you see that, one ID maps to all of these things. And so it's all about the data, the context, and the interaction. I think these are the three important things, not necessarily mapping, one software entity exactly to some artifact or some piece of code in the software. Yeah.
I think when we get to use OOP, but for most developers who come from the OOP background, I think one of the best ways you explain OOP is, mapping a real world entity to a class, right?
Yes.
It's a class. You can have an instance of a class, which is an object, and this instance could have attributes and can perform methods, right? Yeah. So I think it fits into the whole idea of trying to map out a real world entity. But however, as you have mentioned, when you take this idea to the extreme and you say, I want to map out the real world every time with my software, it might not always work. However, I think it still has its place, right? Because the point of mapping out real world with code leans into the idea of abstraction. So do you think the abstraction is being done the wrong way, or do you think mapping the real world is not the right way? We've heard of OOP, we've heard of functional programming, we've heard of data driven I can't remember what they call it, data-driven programming or something like that, data-oriented programming. Yeah. So we've heard of this concept. I mean, and you could actually take a language like Java, which works with classes, by the way, and still do functional programming there, right? So do you think OOP is the problem? Do you think trying to map out the real world is the problem? Do you think abstraction is the problem? Where do you think this mapping of the real world thing gets wrong, and what then is the solution?
Okay, so I think where we kind of get, the OOP is not a problem, because OOP is just a way to get stuff done, right? Okay. Similar to functional programming. OOP is just a way to get stuff done. The real problem is in trying so hard to have this one-to-one, mapping, between, some software construct. It could be a struct, it could be a class, it could be an object, it could be anything, right? Yeah. It could even be a row in a database table, right? Let's forget about OOP objects and all that. It could just be a row in a database table. The thing is, how are we thinking about it? That's the problem. It's like, how are we thinking about it? Do we think that that particular item only exists in one specific abstraction or one specific way, or interacts with the system, the rest of the system, in one specific way, or in a specific set of ways? Because tomorrow the requirements might change. It might be, oh, this can also do this. This particular entity can also do this, right? So it's in how rigid, that's where the problem is. It's in how rigid we try to associate one thing with something else in the real world. Just because we were told, while we were gathering requirements, that, okay, this particular entity does this exactly, and we just want that one-to-one mapping, to that exactly. For instance, you have a product in an inventory, right? Now, one person could be speaking about it in terms of as merchandise, something to be sold. Another person can be speaking about it in terms of liability, all right? Breakage requiring insurance, right? Now, they are both referring to the same thing, but the context is what? Is very, very what? Very different. So not being rigid and allowing, that particular software artifact to flow into different contexts, which is what DDD tries to highlight with ubiquitous language, right? Which is that we can be referring to the same things, but with different names. I could say customer. I could also say user account. I could also say addressee.
Yeah.
If we are building a ride-hailing app, once the user is participating in a ride, they are a rider. But before they are participating, they are a booker and things like that. So the fact that you can have different names, and those names are important because it speaks to the context under which they operate, and also the interactions under those contexts. So I think, so I think not focusing too much on that one-to-one mapping is the problem.
Okay. Yeah. Right. Very much. I think it's important to have that highlight there, that the problem here is the rigidity. Yes. Thankfully, paradigms like solid principle helps alleviate problems like that. I mean, you have the open closed principle, that is the O in the solid part, that talks about, software entities should be open for extension but closed for modification. That way you are able to adapt your entities to whatever problems or whatever new requirements pops up. Thank you very much for that clarification. Let's move on to GraphQL as a real anti-pattern. That to me is like a very, very strong language there. So you said GraphQL is becoming an anti-pattern. Why do you think so?
Okay, GraphQL, when GraphQL came on the scene, it was more about if you don't mind, can I just give one last example about the whole real world thing?
Okay.
Just before I jump to. So if I may ask, what is the difference between if you are building something like a Reddit like or X.com or Twitter like application? What is the difference between a post, a comment, and a direct message? What's the major difference between these three?
I think, as you have said, the major difference is the context, and I think who it is addressed
to. Yes, the context and who it's addressed to, but like on Reddit, for example, everybody makes a post, everybody can make a comment, right? So they have basically the same nature across board, right?
Yeah.
And they can also make a direct message. But if we are looking at just that entity, a post, a comment, and a direct message, is there any major difference? Okay, let me change the question or improve the question. Is there any major difference between these three that will warrant them to be put in separate tables, separate database tables?
Right. I think so. Yeah, I think there are differences that warrant them putting them in different tables, right? Because you want to perform queries, you want to perform indexes, and this requirement would require you separating them. For example, say you want to retrieve a message from a particular user, right? Or let's say you index, in the Reddit application or even X, you have a post being fanned out to different subscribers to that post. For example, when you post to a particular subreddit, people in that subreddit, is notifications being sent out to them, right? When you post a comment, you might not get a you may not get a subscription to that particular comment. So it makes sense to think separate these things in different tables. Why? Because when you're performing subscriptions on every entity that comes into the post table, right? Like the main post table, right? You perform indexes there because people will search on that. And having comments, messages, and posts in that same table might impact indexing performance, might impact search queries when people are searching on a particular topic. It would impact performance. So it makes sense to separate in that context. Also, I think from the context of design or even writing code, right, it becomes easier to think about a post as a post table, it becomes to think about a comment as a comment, rather than thinking of a post comment and this as they're all the same thing. It is this particular enum is comment, is post, or is this that differentiates them. It's easier to make mistakes there. So I think these are reasons why you won't put them in different table. And that's why if we talk about migrations, that's a different case entirely. Yeah.
Okay. So yeah, everything you said, is quite spot on. But then again, you made mention of being able to have notifications for posts and for other things, right?
Yeah.
Yeah, and you also kind of like you alluded to, okay, you need to separate them instead of putting them in the same table for them to have like an enum that signifies that this is a post, this is a comment, and this is a direct message.
Yeah, from the concept of writing.
Yeah, exactly. However, are you considering query performance in all of this? Because
yes.
So you said you have indexes, right? Across the different tables, okay?
Yeah.
But is it possible for us to make a case that self-joins are inherently faster than cross joins or joins across multiple tables. Do you agree that we can make that case that a self join is faster than joins across multiple tables? And that's a self join on one table where you already have indexes, right? On those tables, you can also make them faster. And on that same table, would you agree with that?
I would agree with that, right? But if we're to focus on that, that would be focusing on one point as a reason to, keep these tables together. When you look at even other things such as use cases, right? For example, DMs now are kept one-on-one. There are certain people that see it. Comment, everyone should see a comment, or at least most people should see a comment. For posts, several people should be able to see a post. But when you deal with like different things, these entities do. When you deal with their different purposes, their different contexts, their different use cases, and their different querying patterns, I mean, it makes sense to keep these things separated. So yeah, we can make a case concerning self joins, being probably faster than cross joins. I mean, I'm not really knowledgeable on that particular topic, but I do think that the performance hit would be negligible, right? Because you're performing a self join, you're performing this join against several entities. I mean, probably times 3. So if say you're dealing with DMs now, you probably would have say we're dealing with posts now. Posts among all these 3 entities, posts will be the fewest, right? Between comment, post, and DMs. Posts would likely be the fewest.
Yes,
for DMs, interactions. So imagine I'm performing a self join on that same table. I'm just dealing with the post, right? I'll be dealing with more than times 7, times 8, or times 10 the needed amount of entities I needed to perform this query against, because I'm dealing with post, right? Post might just be 1/10 of the entire content in that table. So I'm performing a self join against like 9/10 that didn't need to be in that context when this this search is being performed. So yeah, self join might be faster, but in this case might be negligible because of the extra entities in that table.
Okay.
But by the way, I'd like us to close this up, so go into GraphQL.
Okay. But if you just give me just 1 minute, then I'll go over to GraphQL. The point here is in how you arrange it. I think you are thinking from the perspective, I'm not sure, I don't presume to know your mind, but I think you are thinking about it from the perspective of using enums to mark a post, a comment, and a DM. But I'm thinking about it the same way you think about commit histories, where you have a commit has a reference to a parent commit. So a post has a reference to, a post has a reference to null. So the parent ID is null, and a comment has a reference to the parent ID of a post, and so on and so forth. And a DM message. So when you're filtering, when you're making your queries, your select queries, you're filtering on parent ID, channel ID for something like a direct message and things like that. Anyway,
then how do you explain this to a developer that's been onboarded, right? You have to write extensive documentation for this. There is a possibility of having a mistake in your code base. I mean, you might write tests, you might have tests in place. There is a possibility of you have this code base that are extended to you have like a couple 100,000 users. The code base is sufficiently large, and then you get into the definition of what is a post, what is a comment, what is this. You have to answer this question over and over again. And mind you,
okay.
In case of Reddit, comments are nested. In the case of X, comments are also nested. So you could go down infinite nested trees of comments. I mean, you know the classic Reddit comment section that's diagonal like this.
Yes.
Because
yes.
I mean, you tend to now define these entities using complex language, complex requirements, right? Rather than I see a post table, this is a post table. I see a comment table, this is a comment table. I see a DM, this is a DM.
Okay, for us to wrap it up, I'm moving to GraphQL now. For us to wrap it up, you are thinking about this from the point of view of real world. This is a post, this is a comment, this is a direct message, but all of them are messages, right? Okay. And they can all have reactions. They can be voted up votes, down votes, all of them. So they are all messages, right? And I believe that if we represent them as messages that have relationships from a child to a parent, I think that, things, because on the documentation, I just have to set, make it very clear once and put it there that this is how we are representing it as a parent ID, a chain of parent IDs. Even if they are deeply nested, it's just a chain of parent IDs, just the same way you can chain commits, right? And I believe that, but, let's move on.
Yeah.
So,
yeah. So we want to keep the answer short so we can go through GraphQL quickly and see if we can pick up one other topic before ending the session. So what do you think about GraphQL? Why do you say it's an anti-pattern?
Okay. So, so the thing about GraphQL is what we were sold initially was overfetching, underfetching, n+1 queries, we have to avoid those things, right? So we fetch exactly what we need and we get back to what we're doing, right?
Yeah.
So the problem with GraphQL is that it's, okay, the problem with GraphQL is that you have, first of all, there is this gap, between how the resolvers, GQL itself, and whatever the resolvers are executing. Of course, they will make API, REST API calls, or they will make a direct DB call, right? To a database, right? To fetch data, right? Each resolver, right? But there seems to be, there is not a GQL as a DSL for fetching graphs, right? If you like, does not have a one-to-one correlation between itself, GQL, and SQL, or say MQL for Mongo, right? There isn't a one-to-one correlation. Like, it's not as expressive as, GQL is not as expressive as SQL or MQL. So that lack of, I'd like to call it impedance mismatch, can mean that certain queries will be fast, right? Certain queries, certain GQL queries, they'll be fast when they are translated at the resolver level to, say, MQL or SQL. But certain queries will now be what? Will be slow. And certain queries might have to execute, multiple, queries, like N queries, just to be able to get the data that is needed. That's the first one. The second one is, there was this idea that ran when GraphQL was very, very popular and everyone was using it, that says, you have to shape your data, right? According to how your front end works it. So you have to shape the data according to how, so the shape of the data follows basically the shape of the UI.
Okay.
Do you get that? That used to be something that was, but I mean, we found out that
I think it's called backend for front end stuff. I think that's what it's called, backend for front end.
Okay. Yeah. Okay. Yeah. So, well, not backend for front end. I think it's. I mean, I'm not disagreeing with you, but backend for front end is kind of like, creating a specific backend for a particular, for the peculiarities of a particular front end. Here, I'm focusing on just the data.
Okay.
Yeah. So for like mobile devices, you have a backend for that. For web, you have a backend for that. So the peculiarities of that, the device that is receiving that. So you can't ship HTML to a mobile device because it doesn't know what to do with it. So, but here I'm talking more about the data itself. I'm focusing on the data. So yeah, somebody saying BFF is not only for GraphQL. Yeah, that's right. So I'm focusing on the data. So the shape of, the data follows the shape of the interface. The interface, the shape of the data. So the requirements, the data requirements and the data shape that the client needs, or the interface, the user interface needs, that's how you should shape your data, right? And I mean, there's been countless articles written by other people, not just me. I think even the creator of HTMX, Carson, has written about this. The creator of HTMX has written that it is not the front end that determines the shape of the data. The shape of the data is determined by the back end, right? So the front end doesn't determine the shape of the data. But then the front end can shape the data in however way. It just needs to request, to the back end, get the data it needs, and shape it the way that it wants. I think there are articles that have been written by the creator of HTMX that also supports basically this idea. And lastly, I feel that GraphQL is it's a niche tool, and it's too niche. It is usually for cases where the front end, the data needs of the front end or data requirements of the front end doesn't change significantly or over a period of time, doesn't change on a very high frequency over a period. So things like you have Jamstack. So Jamstacky kind of where you have like a headless CMS, trying to get data to the front end. Yeah, Gatsby used to do that in those days. So you had Gatsby. I think you can do that with Next.js, where there's a GraphQL backend. I think even headless WordPress has GraphQL, and that's perfectly fine. Having a GraphQL headless backend that fetches data once and it's displayed, and you don't have to kind of like refetch that over and over again over a period of time. I think that makes sense for GraphQL. But anything where the client is very chatty with the backend, GraphQL kind of falls off in terms of like, the performance. That's basically what I believe. Yeah.
Okay. I think so far, what you've made a number of points might be subjective. So just to clarify and to take out the subjective nature of the question, I'll just ask one question on this. So I would say,
Okay.
For teams that are still using it effectively, you mentioned that GraphQL would be used in cases where data doesn't really change frequently and when data isn't really fetched frequently. And you also mentioned that it might impact performance. Some queries would be slow, some queries would be fast. You mentioned that as problems of GraphQL. So
Yes.
for users that are still using
it has mismatch between GQL and SQL and all that. Yeah.
I see. Yeah. So for teams that are using it effectively, for example, GitHub uses GraphQL at scale. In fact, the GraphQL API has more user rate limits than the REST API. So there must be something they are doing right. There's something that works really well for them that is way more efficient for them to use GraphQL. Given GitHub, you know how big GitHub is. So there's something they would be doing right. In the case of Hashnode, same thing here. Dealing with Hashnode, and they fetch data frequently. I mean, you have Hashnode headless Hashnode where you can write your own front end and deal with Hashnode GraphQL backend. Hashnode uses GraphQL, by the way. I don't think they have a REST API. They use Hashnode. Now you have this API, Hashnode's API, GitHub's API, where you're dealing with different types of entities. If you've checked GitHub's API, you would be stumped by the number of entities, by the number of things you might have to fetch. And being that you're dealing with different interfaces, different plethora, different combination of interfaces, it might be that data will be fetched frequently, as opposed to what you mentioned, that data is being used in cases where data is not being fetched frequently. Data will be fetched frequently in these cases, and the requirements of the UI in these cases are different. You're calling GitHub's API, people are using for different use cases. For example, for internal developer portals, you're grabbing certain entities to provide a reward mapping of your stack to users. For if so, you are building a clone of GitHub for people to use, you are copying the entire stuff, and you want a different interface. In the case of Hashnode, you might be using Hashnode for to power your comment section. That's not what it's built for, right? But you could use it to power your comment section. You could use it to power your list of articles. You could use it to power a blog post. You could use it to power anything. So these are use cases that goes against the requirements or the needed circumstances that you have said. So what are they doing correctly?
Okay, so I love that you gave these two examples, GitHub and Hashnode, right? Because I have looked into them. Now, Hashnode is a blogging, it's for blogging, right? You know, you have articles, you have list of articles, you have all that. Most people power their comment section with Discourse. I'm not really sure that if I think I've looked at Discourse a while. I'm not really sure they have a GraphQL endpoint. So you were speaking to the volume of the entities, like the volume of the data, which GraphQL can handle really well. Like GraphQL handles large volumes of data really, really well. I think I failed to mention that. So, you know, let me mention that now. However, these two examples you've mentioned, GitHub and Hashnode, when you fetch a list of articles, does that data change in a long, does the list of articles you've written, let's say over the space of 3 months, for example, does that data change? Is it very dynamic?
So generally, public API schemas don't really change, so you could apply this to REST API too.
Okay, when you're doing fintech, does the data change very frequently? When you're doing things like balances, you know, things like transaction, list of transactions, does that data change dynamically?
I can't say to that. I can't say to that. I'm not really in the fintech side, so I don't. But I imagine it doesn't.
Okay. But if you were to compare it, even though you don't do fintech, if you were to compare it with Hashnode, like a blogging data, list of articles, the article content itself, does it change highly, like very dynamically over a period of time? Compared to like balances on a fintech app, yeah.
For GitHub and Hashnode, no.
They don't change frequently. So that's what I was referring to. For GitHub, list of repositories don't really change that much over a long period of time. So GraphQL, like I said initially, GraphQL is excellent for those cases. And that's why Gatsby, with Jamstack, back then you had Gatsby with Jamstack. I loved their GraphQL listing. But for when you now apply GraphQL, that's the only niche area where I believe I would love to be wrong, seriously. Maybe I'm wrong. Maybe GraphQL isn't an anti-pattern, but I really want someone to kind of like it, because we are all here to learn, right? So I'd really want someone to just tell me that, oh, there's this where the data is very dynamic, it's changing frequently over time, right? Something like stock market data.
So like generally, are you referring to the structure of the data changing, or are you talking about new instances of that data popping up? Which one are you referring to?
Okay, yeah. Thank you for that question. Let me be clear. I'm talking about not new entries, not new instances of the data, but I'm talking about the data itself, like changing frequently. Do you understand what I mean?
Okay, okay. You mean like updates to the same data changing? Is that what you mean?
Yes. So
right.
Yeah. So updates to let's say a repository name. Let's say updates to repository name. How often does that change?
Okay, that doesn't change very frequently. Okay.
That doesn't change. Yeah. So that's kind of all the contents of an article. How frequently does that change?
Might not really change frequently. But what's the context between GraphQL and data changing frequently? I imagine this doesn't impact REST API either, and I do not think it really impacts GraphQL. I mean, still the same GET request. Sorry, post request.
Okay. Yeah. Like I said, I'm happy to be wrong, but I've seen instances where teams have switched from GraphQL to REST simply because the data, they were working in a particular domain where the data was changing like frequently, not new entries, not new instances of the data, right? The data itself was kind of like changing, like really, really frequently. Updates, mutations, they were really, really, changing, frequently. And yes, GraphQL has mutations and has queries, but
Okay.
then I've seen where teams have moved off. I've read countless articles. Well, not countless, but have read a lot of articles where teams have moved off GraphQL and moved to something more REST-like. It may not be REST, but more REST-like because of
that changes.
High frequency of data change. Yes, I've read these articles.
Probably skill issue. Permit me to say they are probably JavaScript developers.
Yeah. Okay.
It's probably a skill issue, right?
Yeah, maybe, yeah, perhaps, yeah.
Yeah, because I see GraphQL as solving a particular use case where you want to fetch data you need. In fact, I do not think it's a case of data changing frequently. Instead, it's a case where you have requests that would potentially return huge volume of data, right? For example, in the case of GitHub, you have everything that happens within the context of a user or an organization. By the way, to link to your real world mapping scenario of a thing, an organization is almost similar in GitHub, but they are far from being the same thing. So everything happens within the context of an organization or a user. Now, you have so many entities you can pull from a user. You could pull their pull requests, you could pull their repositories, you could pull their comments, you could pull their files, you could pull the readmes, you could pull the description, you could pull reviews, you could pull so many things, issues, and so many things. And in that particular use case, someone probably just wants to list repositories, right? They don't want to see any other thing around repository. And this request with a REST API would potentially return lots of information. Now, this is not needed, right? So it makes sense to have a GraphQL endpoint where you request only what you need. And then this works out. Now, it's now up to the team who wants to implement GraphQL or REST to determine, does this really fit our use case? Do we really need it, right? Because if you have a case where, I mean, you're dealing with resolvers here, right? If you have a case where, if you want to fetch data, maybe you're fetching a repository name, and then you are going down to just fetch, say, something like a review comment, right? You see the gap between them, a repository and a review comment. You still have pull requests over that. You still have reviews over that. Then you have a review comment. You have this, the relationship is quite distant. It makes sense to use GraphQL because I'm just grabbing just what I need. My API is not going to take so long. But the REST API, you would make multiple calls. So in that case, GraphQL possibly might even be faster, right, than REST APIs in this case. So I think it just works. But at this point, let me open the floor to the audience to ask questions. I mentioned initially, okay, someone said I disagree with you saying skill issue. We moved from GraphQL to REST because of this issue. The issue is you decide the trade-off you want to give priority. Yeah, I was just joking about the skill issue of it. I don't mean it seriously. I mean, them moving from GraphQL to REST because they had changed frequently did not really make sense to me. So I think the skill issue, except there is a particular use case. I mean, that's right.
Yeah, and if you give me 12 seconds, I think what you're saying, GraphQL could be faster. Yes, perhaps, maybe. But then, have you considered the possibility that, because like you said, the relationships are far apart. So GQL on the resolvers or at the level of the resolvers, it's executing all those queries, but it's not returning the data. It's returning only what you asked for. But it's executing the queries to get through the intermediate relationships on the resolver level. Have you considered that might be happening?
That's a data mapping peculiarity, right? It's different from the GraphQL interface itself. For example, you mentioned that a comment and a post is the same thing. If you're designing Reddit, so if you had to give me a GraphQL API, if I to based on your data modeling, if I had to request, all my DMs, all my posts, and all my comments, I'm basically querying the same people. My resolvers would be fast, blazing fast. Putting indexing aside, my resolvers will be blazing fast. So I think it's a data mapping problem. We can't apply it to all use cases.
Okay. All right.
All right. Okay. Thank you very much. I want to take questions from the audience or submissions from the audience. I think we've discussed with the hot topics, and people are bursting to say something. So if you want to say something, could you raise your hand? I have one person in the queue right now. things could get heated up quickly. So raise your hand if you have a question now. Emmanuel, you can go ahead.
Good evening, guys. Can you hear me clearly? There's a bit of
Yes, I can
background
hear
noise
you
here.
clearly.
Yes.
I can hear you.
Yes, amazing conversation you guys have been having, and I've been enjoying both sides of the, enlightenment. That's why I would put it for two different opinions, and yet we're able to stay, get to a compromise. But I think I have some point of view and then a follow-up question for it. So, when I saw the topic of the
All
of
right.
the of the DevMeets, I really enjoy that topic because I'm one person who also enjoys going against the so-called industry norms. I think a couple of people in the community know I don't like object-related programming. I'm so functional. I don't like the model MVC pattern. I try to go against it as much as I can. If I see a loophole, I try and believe I am right on that particular scenario. But I think foundations, I think that's where my question wants to come from. I believe we want to discuss whether something has been considered an anti-pattern is actually not an anti-pattern, or we have an argument against it. It will be founded based on the evidence in the sense that performance, we get performance gain. They said we get performance losses, but obviously they are wrong. We still can get performance gains if we do it this way, then we would all agree it's not an anti-pattern. Take, for example, say GraphQL, like you mentioned. I think the inherent design is just for the client to be able to request whatever data they want, no matter how much there is. So I don't know if you agree with me there. So say you have maybe just a user object for a Google user, for example. That singular user object probably has entities relating to Google Maps, Google Docs, Google Drive, Google Mail. There's a ton of artifacts, there's a ton of data stored for that singular person. If we build REST, which is the de
Yes.
facto standard, and now we build it, you just have to send everything because you don't know what they need, you don't know what is not needed. And just the cost of serializing that data or the cost of sending it over the wire to the front end and all of those things at scale now, at Google scale or at
Yeah.
Facebook scale, it can be quite, it can
Okay.
add up very quickly. So if
Yeah.
you have clients that
Very,
can, for
very clear.
example, take requests, I just want the username and password. It takes just a couple of bytes, send it over to me. But now I'm in control of what I need. You don't have to give me endpoint that gives me just Google Drive data or Google Maps data. I can just hit one endpoint and say, here's what I need, and here's how you should format it and respond to me. And they send it. So in my opinion, I would like, say, maybe an in-depth example, even if it's not GraphQL, like you said, or maybe something where it is an obvious anti-pattern, and here are the reasons why everybody says it's an obvious anti-pattern. But if we look at it from this lens, this is wrong because we get this, and that is wrong because we get that. Let's not bury ourselves in the sea of terminology. You get me? I'm saying, can we get maybe performance, something like that? That's my question. I don't know how you did if I communicated. Thank you.
Yeah, I think I get your question clearly. Do you want to go ahead to answer the question?
Okay. So it's not like I can show benchmarks here, for web performance, but I think here's one thing I would say. All indirection comes at a cost, right? All. And GraphQL is an indirection between your clients, all right, and your database or REST API, because the resolvers are still either calling the database or a particular REST API, right, to fetch that data. Okay. So, and the way I look at indirection is that if it costs, then I have to receive a benefit that outweighs that cost, right? So there has to be. Sorry.
Go on.
Yeah, I thought someone said something. So there has to be a benefit that outweighs that particular cost, right? Now the benefits.
So in your own case, if you're, what would be the benefit then? Please go ahead.
Okay, so no, I'm basically explaining that if I'm setting up an indirection, it's just the same way a virtual DOM in React is an indirection. It comes at a cost. Every indirection comes at a cost, but there is a massive benefit for the VDOM, which is that it efficiently updates the DOM. It doesn't update the DOM unilaterally. So bringing that back to GraphQL, the benefits as listed, right, is no overfetching, no underfetching, because with REST, you get to overfetch. You fetch the things that you don't need, right? And you sometimes on some pages, you kind of underfetch the things that you need. So you need something, but you underfetch, then you have to go back and fetch. So kind of like the n+1 queries,
Yeah.
right?
Yeah.
Idea of n+1.
All right. Sorry to disturb you. I wanted to add another follow-up. You know, let me put it this way. Like you said, indirection and the cost of things. And I think overall, right,
Okay.
in my opinion, you know, in my experience, overall, when we get to make choices on what tool to use for what job, is also often based on what's the benefit and what do I have to incur as cost.
Is the cost.
You know, if you throw a queue into
Yeah.
a system, you have to have dependencies of, say, Redis, or even if it's a basic queue. Now you're thinking, now I need to provision extra infrastructure just to get these extra benefits, right? So
Yeah.
let me give you an example.
Exactly.
And I also think there's something called constraints that I think causes us to go the other route too sometimes. That's why we have options. Let's take, for example, one of the first things you mentioned about nesting comments. It can be real faster to query, right? In very simple systems. But imagine Instagram did that. And Rihanna posts a picture on her birthday, and for whatever reason is controversial, and it gets 10 billion comments. Now, it means in a single Instagram post, you have just embedded 10 million items into one. How do you send just 10 of that post over the wire to the front end? Say I'm the
Right.
mobile app, I open my device and you grab it, because now you can't even it's not going to be even easy to query the comments alone out of the system without incurring even greater cost. Or would it be easy to even paginate fetching that comment, because now it's nested? You have to grab everything as a whole with let's just say even a million comments. If you have just 20 of that post and you grab it from the DB, it's going to eat up virtually all of your memory before you can store it. You have to serialize them. You have to send them over to the front end. The cost is probably going to take 30 seconds to send such a post from whatever server somewhere. So how do we look at that now? And when people before us have tried such in the past and said, look, at scale, here's what we face. We can't do it. You should separate it. It's not just for aesthetic reasons. If you need it, you fetch it.
Right.
If you want to join, you can populate or do a join or do whatever you want. Here's the cost we're incurring now, the cost of joining them when you fetch first, or the cost of doing whatever. So I think what I'm really looking for is, if you tell us that is not genuinely an anti-pattern, when they give us facts, I don't know if I qualify it as facts, like we have tried it, this is the result, and this is what we got, we suffered. And we see the obvious disadvantages. How would you take such an example now? Say, maybe give us scenarios or situations where that is the right pattern to use. I don't know if,
Okay,
if you can tell me.
I'll give you a real world scenario. Sorry, you wanted to go?
Yeah, I just wanted to add like a statement. I mean, yeah, in the case of Instagram, like that, under Rihanna's post, I mean, and you have cases where, especially with Reddit, where because of that nested comment pattern, people have developed, a certain way of interacting that fits within that style. So you would have comments, say you have a billion comments now, you'll have a particular comment chain that could be like a million lines long. Let this person types a sentence, this person types on that sentence. For every API call, they are incurring the cost of my salary for every API call. I mean, so yeah, I would love to hear the answer to that question.
All right, beautiful. Great question, Emmanuel Olaseni. I hope I didn't murder your name.
No, it's cool.
All right, okay.
You did, but it's fine. It's
All
fine.
right.
Please go ahead.
All right. Okay. So great question. Thank you very much for that question. So here's my response to that. Now, going back to your example about Instagram, right? If we not just Instagram, if we look across most social media, right? Nobody is going to query for 10 billion comments at once, right? That's if you look across, not just for Instagram, across all social medias, TikTok, Facebook, nobody's going to do that. Whether with REST or with what? With GraphQL. Nobody's going to do that. So, I mean, the way Instagram works is once it fetches the post, it will fetch only the top level comments. That's the comments that are direct replies to the post. And it will fetch a specific number of them. It won't fetch the replies of the replies. I don't know if I'm making sense. It won't. You are the one who is going to prompt that action. So it lazy loads all of that because it knows that there is no point fetching the 10 billion
Sorry,
ahead of time.
Ifeora, I think what you just
Okay.
explained now suits the pattern of separating. You know, I don't know if you understood what I said. For example, you have a post, and what you store in the post is just the post ID, maybe the post title, maybe the actual URL of the image. We're talking Instagram now, you know, maybe the actual
Okay.
URL of the image on a CDN or whatever. Then you have a reference to the user object, maybe the user ID, so you could, you know, join it and display the post. Now you have
Yes.
comments. Let's imagine it's an array. You want to let stuff inside now. For every comment that is posted, you'll be pushing it into the array. That's the anti-pattern you said you might probably recommend, right? Now, if you push 1 billion of that, or even just 1 million of comments into the array now, it means for just one post in the DB, that singular post has an array that has 1 million things nested inside of it. You can't go to the DB and say, give me just the comments. For most DBs, you can grab the entire document just as once. You can say, you know, for this document, go to the field of comments and then look into the array and grab me for. You are going to do very expensive computations, like Ayodeji said. A single query will probably pay all of us salary on this call, you know, because it's going to spend a lot of time grabbing the entire, copying the entire 1 million that is nested inside this array into the memory. And that's not a small number. And that's just one document. So imagine Rihanna post, Drake post, Whiskey post, Davido post, and that's the first one that wants to show up
sure
on
I'm
my feed.
understanding. I'm not sure I'm understanding. So I'm not sure I'm understanding the question now. Because
So my
I think
question is, I think you advocated for nesting comments inside post. That's what I'm asking. That's what I'm
nesting
saying.
comments.
If a post for whatever
No, I
reason
did not
garners
say
even
this comment.
100,000
No.
comments, how
You
would it work?
misunderstand. You misunderstand.
Okay.
I think after now, I'm going to add, this is something I've done. I'm going to give Ayodeji a link to a database fiddle that shows my idea, that shows the actual implementation of my idea. I'm going to give him, I think, when he edits the description of the YouTube video, he can post that link. It's going to be a DB fiddle. I've done it already. Okay, so you are saying that, you know, are you saying use a document database to embed comments inside posts? Is that what you're saying?
What would you recommend actually? That's what I'm asking. That's the
Yes.
question. How would
Okay,
you
so what I will recommend
store it in DB? That's what I'm
in the
saying.
DB. Beautiful,
That's the
beautiful.
anti-pattern.
Okay.
Yes.
All right. So I get the question now. So here's how, like I said, I will give Ayodeji the actual fiddle, the link to the fiddle that implements this and executes queries on it. And the queries come with timing. So, you know, I don't have the link right here, but I'll give it to him. He will post it in the description on YouTube of this video. You know, it's currently streaming on YouTube, so he'll post it there. Now, let me answer your question. You're not embedding the comments inside the post. You are creating a hierarchy. It's hierarchical data, right? So you are not embedding because you're not, in my example, I don't use a document DB, if that's what you're saying. I use my SQL, and a relational database table. That's what I use in my implementation, which I'm going to send, the link I'm going to send to him.
All right.
Yeah, so here's an explanation, very quick explanation, so that you know, we can get others to ask questions quickly and so that we don't waste the time of our lovely host. So it's hierarchical. A post is a row in the table. A comment is also a row in the table. But there is a column called parent ID that, you know, links to that, right? So there's no embedding going on. It's hierarchical, right? So the parent ID is null, if the parent ID is null, it means that is a post. It's a top, you can think of it as a top level comment that has no parents attached to it.
Sorry to cut you short. I don't want us shifting the focus, right? On the GraphQL part of things, because we'll enter into, why should it be next, why should it have a parent and all of that. So on the GraphQL aspect of things, yeah, let's focus on that. So to answer the question, why would it be an answer pattern? Because I believe, the idea of nested comments right now, we are not saying that, I believe three of us, we all understand that we are not saying that it should be nested comment or it should not be nested comment. We are saying, let's assume there is a case like Instagram where they have nested comments. Let's assume they decide to go the nested comment route, like Reddit, right? Why is it an anti-pattern case of Instagram or any other case where GraphQL would be an anti-pattern? I hope, do you understand the question?
Sorry, come again. I want to get the question.
We are saying that let's assume Instagram decides to go the nested comments route. Let's assume they decide to have nested comments. You could nest comments the same way Reddit does theirs, right? Let's forget about semantics around whether post, comment, and DMs are in the same table or all of that. That's not right. So what I'm saying, when we have a case like that, say Rihanna makes a post and you have several comments, millions of comments there. Why would REST be an anti-pattern? Sorry, why would GraphQL be an anti-pattern? And if GraphQL is a great use case in that scenario, what is a use case where GraphQL wouldn't work?
Okay. All right. Okay, now I get the question. So GraphQL, I think when I was speaking, I think the point that I was making has been taken to. So we are now looking at use cases, right? Which is what your question is focusing on. We're now looking at use cases where GraphQL isn't great or will be an anti-pattern, and where it won't be, right? That's what we're looking at. Okay, so GraphQL in the case of like Instagram, right? In case if they decided to implement nested comments, right? GraphQL has that ability to nest, things, but then you would have to. So you have posts, and then posts will have comments, right? And then those comments will also have. So you can go deep into the graph and all that sort of thing. Now, you would have to specify on the GQL side of things. So on the client side, when you're defining the GQL, you would have to specify how deep you want to go. So that's something that GraphQL, because GraphQL does not have the ability to tell you, oh, go all the way, right? So I think that kind of like links back to what he said about 1 billion nested comments, right? You would have to specify how deep you want to go, right? And then GraphQL does, the fetching, right? Now, the thing is, with GraphQL in that instance, right? GraphQL has to execute, because if you go too deep, there are cases where if you go too deep into your nesting, your GQL nesting, you could exhaust resources on the server, right?
Yeah.
Right? There have been cases like that, GraphQL cases like that, where you go too deep and you exhaust resources on the server. So you have to limit the depth, all right, that your GQL can go, right? And you have to enforce that limit on the server, right? Because attackers can use it to cause a denial of service on your server. So the thing is, it depends on not just the use case, but it depends on what is beneficial, right? In the case of this whole scenario, it depends on what is also beneficial or what seems meaningful to the business and also to the end user. So not just in terms of the use case, seems what's beneficial to the end user, what's beneficial to the business. So you could execute the query, right? But then you would have to have a limit, right? Because if you go too deep, problems can arise, right? But that problem arising is not an indictment on GraphQL. It's just the limits of GraphQL. It's not an indictment on it, right? But what I was trying to establish, still focusing on use cases now, right, is that you can, yes, GraphQL gives you this freedom to execute any sort of query that you want, right? And because it uses a post request, you can request large amounts of data, right? But then if we look at practical software applications that we build, from Instagram, social media apps, to maybe let's say fintech, stockbroking apps, e-commerce apps, right? What are those cases where GraphQL can do something? This is a rhetorical question. I'm not expecting you guys to answer. But what are those cases where GraphQL can do something that REST can't? What are those cases where it can do something specifically for something that benefits the end user and also benefits the business, right? Because in the case where you have infinite nested items in the GQL, that doesn't benefit anybody. The server crashes and that doesn't benefit anybody. It doesn't benefit the end user. It also doesn't benefit the business, right? And the business incurs bandwidth costs, right? Now, again, if you're fetching large data, the business, if you fetch that data over and over, this is why I said it is when the data is changing over and over again. If you're fetching a large, like you said, fetching large pieces of data, because post requests can return larger data than get requests, right? Which is why GraphQL uses post requests. It can return larger entities than get.
So you mean request payload?
Yes, post requests. Yeah, they are larger. This is spec on the level of the spec, the HTTP spec. Yes. So, which is why most times the default is a post request for GraphQL, queries. Now, that if you are making that request over and over and over again, you see that bandwidth of data, you are fetching it. So in about, say, the space of 3 seconds, you fetched over maybe 20 KB of data. 3 seconds, 20 KB. Multiply that by 60. That's 180 seconds. If you keep doing that, that is going to put serious, cost implications on your server, right? In terms of how much work it is doing and how much data is sending back. This is why I said GraphQL is, and that does not benefit the business, right? In terms of the server costs, that doesn't benefit the business, right? So, and there are cases where fetching that large amount of data in one fell swoop, right, isn't what the end user really wants. Like the end user just wants to see a couple of comments, right, at a time. Just a couple of comments, not the whole nested, like the way it is in Reddit, the whole nested bit. They just want a couple of comments. If they want to see more, they just click something that loads it, right? So that fetching all of that large data is not something that also benefits the end user. And fetching that large data frequently, so over 20 KB, 3 seconds, multiply that by 60, that's 180 seconds. Multiply that by also 60 by 20. That's running into the megs. If we're being honest, that's running to about 1 meg, right, of data. And there's also the server cost for that. So the rhetorical question here is, in what cases does that actual quality of GraphQL benefit the software system in such a way that GraphQL is the only technology that can do that and REST can't do it? And the answer to that question, like I said, it's a rhetorical question. The answer to that question is that it's not a lot. Like GraphQL is a very niche tool. It's not a lot of benefits. So having that indirection and maintaining that cost of having the GraphQL resolvers do that intermediate fetching becomes very little. So the benefit is very little compared to the cost of that indirection in between your client and your server, your REST server, or your database server.
All right. Thank you very much. Yeah, thank you very much for your explanation. Let me take one more question. Do we have any more question? Just one question. Just one question. Just one question. Now, it's like more hands because I mean, said quite a bit on the topic. All right. In the absence of any more questions, thank you very much, Patrick, for this session. By the way, to everyone, this has been recorded, or this has been streamed to YouTube, or it's being streamed right now to YouTube, so you could go back and watch it and see other things that were discussed prior to when you joined. By the way, I'll be dropping a couple of links. First of all, you can follow DevMeets on X. You can also subscribe to the YouTube channel. I'd love you to do that. It doesn't cost you anything. You're not going to be charged from your account balance. And you could also, follow me also on X. I've dropped these 3 links. On the DevMeets channel, you'll find past sessions we've had and also UT future sessions. So you could also subscribe on YouTube and then follow myself, the host, also on X. Patrick, would you mind dropping your X link so others could follow you if they would want to? Okay, yeah, thank you very much. This was a wonderful session. We discussed quite a lot. I mean, we had other things on the table to discuss, but I believe even every single topic we discussed was worth a session on its own. But this was beautiful. This was beautiful. Thank you very much. Thank you to Emmanuel for asking the questions and the follow-up to the questions. I'd love to have another session again in the future. We could have another session in the future. But right now, so if you'd like to follow DevMeets and follow up on other sessions, you could just follow the X account. I usually send updates out there on different sessions. If you're a WhatsApp person, I will be sharing you the link to the WhatsApp channel, so you could just follow that, and that also works for you. You get updates on that there. With that, thank you so much for joining. See you in the next DevMeets session. Have a nice evening and have a nice week ahead. Bye.
All right, bye. Thank you very much, everyone. Nice meeting everyone here. Nice conversation.